Hello explorers, it's that time again. It's Advent of Code, finally! And as normal, you can join the channel as a Christmas explorer and see all the uncut content before I publish any video. Day 3, Gear Ratios. You and the elf eventually reach the gondola lift station. He says that the gondola lift will take you up to the water source, but this is far as he can bring you. You go inside. It doesn't take long to find the gondolas, but it seems to be a problem. They're not moving. You turn around and see a slightly greasy elf with a wrench and look of surprise. Sorry, I wasn't expecting anyone. The gondola lift isn't working right now. It's still be a while before I can fix it. You offer to help? The engineer explains that the engine part seems to be missing from the engine, but nobody seems to figure out which one. If you can add up all the part numbers in the engine schematics, it should be easy to work out which part is missing. The engine schematics, your puzzle input, consists of a visual representation of the engine. There are lots of numbers and symbols you don't really understand, but apparently any number adjacent to a symbol, even diagonally, is a part number and should be included in your sum. Periods do not count as a symbol. Here is an example schematics. So here we have a bunch of numbers and a couple of symbols. In this schematics, the two numbers that are not a part of the part numbers are not adjacent to a symbol is 114 top right and 58 middle right. Every other number is adjacent to a symbol, so it's a part number. Their sum is 4, 3, 6, 1. Of course, the adjacent engine schematics is much larger. What is the sum of the engine parts in the engine schematics? So, if we switch over to my screen here, I have already prepared a bunch. So let's look at this puzzle input here. It's 141 times 140 times 140. So we can make this a little bit smaller. Or we can have it like 150. It's 150. So that is what we want to do. We want to change this to day 3. Let's do the sample input first. And let's pick that up here. Point, like that. And I also prepared a class. So we have here number position, which has a start X position and end X position. We should have a private int Y as well. And here we should set y equals to y. So here I have a function where I add numbers. If x start is equal to -1, then we add it there. This x end is always added. So we know where it ends and we know where it starts. Like that. So when we parse this, we need to, of course, take the line, split that into anything, and loop over there. String the character, so just go with a C. And then we want to have X here and Y like that. And for each line we take Y an increment, and for each character we take X an increment. And this character digit again, get the character position. If that is the case, we should have a number position here. That's its null. And we should have a list of number position. Like that. Just so we can have something to put it in. So add number, and here we do x, y, and the character, like that. If mp is equal to null, then we will create a new one. New number position, and else here, if it's not a number, then mp, the list should have a new an mp, and the mp should be equal to null. And of course we want to check if mp is not null here, and then we will add it to the list. So that's something we can do. I also created a map up here, so I want to add the different numbers to this map, and I prepared a bunch of characters here. So let's see. Here we will say if characters contains key C, then we want to do something. Else if C equals to dot, so I want to check it's not equal to dot, then I want to output C, because I want to know if I get something that is not a dot and not in my actual list. So here, first off, we can take this map and fill it. So arrays fill map with zeros. So we know that we have zeros in the map, and then we do characters get C, so we get that number, and we want to put that into the map, add position, and y times 150 plus x. So we put it into the right position in the map. Like that. So now we have a large map, we have a bunch of characters, and so on. So we should be able to do this. Perhaps we should create a print map function. $150 for int x equals to 0, x more than 150, x plus plus, and then we do the same for y. Like that. And then we want to do and print line there, and then just a print here. And we do map y times 150 plus x. So if we run the current file, we should get a pretty big map here. What is the output up here? Yeah, I got the numbers. Okay. And C character is digit C. So it should not be a number either, of course. Then I got to get the big map and a 0. And I should get some numbers up here. Yeah. So maybe I should use the dot instead. If equal to 0, else like that. So we get the similar value as before. But it looks a bit strange here because I get, wait a minute, x should be 0 here. Of course. Now it looks like we are cooking with fire. That was a good bug to find early, so we don't have any problems with that. Now we should figure out if our number position is correct. So here we can take a public is adjacent, and then we can take an int map in like that, and we return false at the moment. So if we take a map in, and then we should look at the map. So for int x equals to x start, and then x smaller than x end plus 1, smaller or equal to is more readable, x plus plus. So there is what we want to look at. And then we want to say is here we want to check for each map x y. We have a y up there, yes. Y times 150 plus x. Let's see here. X plus 1. Is there something there? If that not 0, then return true. That. So that's 1. We need 8 of them. 1 plus minus x, and then 1 plus minus y, and then we do the same for the corners. So all of those should be true, else it should be false. So if we do a for loop here, number position, MP over the list. If MP is adjacent of the map, system out, print line, can do like that, and then MP get number, turn number, like that. So if we go back here, x larger than 0, and here we do these, we do also x larger than 0. $114 and 58. So those are the things that are not. So if we do like that, then take val and add to that MP get number 2, we should get 4,361, and that's correct. So let's make this even more clear here, because I think maybe we can run it with the large set, but it might crash because we might get out of bounds. But let's try it. It didn't. Put it in. No, your answer is too low. Okay. We get a bunch of these characters that we haven't seen. That explains it. Right. So 533,775. Turn to Dave 3. Let's put it in. Yes! You get a gold star. I get a gold star. Everybody gets a gold star. So the only thing we needed to do is have more different characters. And I hope that I need to use those now in the second part. So let's check. This video series is sponsored, so for all your hosting needs, go to DigitalOcean. If you want to learn something new this Christmas, then you can go to Coursera, take any of those 7,000 courses over there, or follow along with the simple Java course that I provided as well. And if you want to give your kids something really great for Christmas this year, you can give them a one-on-one course with a Code Combat trainer in order to learn coding. All the links can be found in the video description. The engineer finds the missing part and installs it in the engine. As the engine springs to life, you jump in the closest gondola and finally ready to ascend to the water source. You don't seem to be going very fast though. Maybe something is still wrong. Fortunately, the gondola has a prone label, help, so you pick it up and the engineer answers. Before you can explain your situation, she suggests that you look out the window. Stands the engineer holding a phone in one hand and waving with the other. You're going so slowly that you haven't even left the station. The exit then goes over. The missing part wasn't the only issue. One of the gears in the engine is still wrong. A gear is a star symbol that is adjacent to exactly 2 part numbers. This gear ratio is the result of multiplying those 2 numbers together. This time you need to find the gear ratio of every gear and add them all up so that the engineer can figure out which gear needs to be replaced. Consider the same engine schematics again. In this part schematics there are 2 gears. The first is the top left, which has part number 35 and 467. So its a gear ratio is The second gear is the lower right, which ratio is adjacent to the x adjacent to 617 is not a gear because it doesn't have two part numbers. Adding up all of the gear ratios produces. So I actually needed this, and we need to figure out which are ones. So it's the same puzzle input, right? So those two are adjacent, but this one isn't adjacent down here, right? Oh, those two are adjacent. I see. So let's get back to our sample input here. So now we add to this number position here. And here we say private int gears. Gears is a list of gear. New array list. Like that. And then class gear is just int x, int y. So that's just a gear. And here we do void find gears, like that. And if any of these are equal to 1, we need to do gears, add new gear, and the gear needs to have gear x, y, this x, this y, like that. And here we want to say y, x, x plus 1, y. Now we have added all the gears, and public int has int get gear, and here we put in a number position. So for gears mp gears or g2 gear if g1 x is equal to g2 x and y is equal to e2 y. Then we want to take can this have multiples? Yeah. Potentially. So this gets number times MP get number. And then we return val here. So that is what we want to do with the number positions. We want to check all the gears. So here we want to check every number position against every other number position. That is our task. And we don't want to check them twice. List size. Y equals to, or J equals to I, J less than list size, J plus plus. I plus 1. Val plus equals to list get I get gear list get J. So what's the value of that? We haven't run find gears. Of course. So for number position MP list MP find gears, the map. Let's do MP2 again. So now we got a large number. And the funny part is that it's the same large number. So maybe I have just created something that works. Maybe. So let's see. We got a really large number. It's in the ballpark of 78 million. So let's put that in and see if that's the right number. Yes! You get a gold star. I get a gold star. Everybody gets a gold star. We solved that one too. Right. So what we did here is that we have first off a map size of 200, which is much larger than we need. And then we have the text input. We have a bunch of characters here that we put in. So we know that we get different numbers for different characters. The only one that is actually interesting is the star, but we didn't know that when we started out. Then we have this map size, so a big map. We were keeping this pattern, don't need that. Then we have a reader that reads through day 3. We have X and Y and val. Are we using X and Y? Yes, we are doing that. And then we have a list of all our number positions, and we have the currently working one that is just MP. And we fill our map with zeros, and then we go through and parse this. And the parsing part is checking if this is a number. If it's a digit, and we don't have a current working number, we will create a working number, and then we will add the current digit to that number. And if we don't find any more digits, then this number is done. So we put it into our list, and then the currently working number, we set that to null. And if we see any characters in our map here, we want to set the characters in the map instead. And if it's not a dot and not a digit, so we have something that we haven't seen before, we want to print that out. And we also want to keep track of our X position, and for each line we reset the X position and add to the line. So that is our parsing function. Then we print out our map, so we can actually see that we got a pretty nice map. We needed that to debug our stuff, so that was really important. Typing it out is just 2 for loops over X and Y positions and printing out either dot or the number that we find. Now in part 2, we wanted to find gears. So we have this find gears function over our map, and then we go through each of the list. So we compare each of them with each other. The reason that we do a +1 here is that we take the first one, compare with all the others, take the second one, compare with all the others that are left in the list, and so on. So we always step one extra over. So we never compare to ones the same. So that is what we do here. And then we get the gear value and add to our value. So let's check number position then. We have a bunch of functions here. So first we have the things that we have up here. We first have the start and end position of the X value, because a number is typed in the X positions. And then we have a Y value, so which row it actually is on, and the actual number, and I have a string number as well. That is used in this add number. So we set the value of Y every time, and then if we haven't a start value, we put that in, and we always put in the end number. So we get those two, and we add to the number string, and then every time parse it. So that is, we might just want to do that at the last point, but it doesn't really add that much extra. Then we had a function here that checks adjacent, where we needed to check the boundaries so that X is not larger than the actual map when we add to X. It's not smaller than 0 when we are minus. So that is everything here. It looks a little bit convoluted, but I only check the cases that are actually needed for each one. We could have a much larger one that checks every case in all directions, but it's not really needed here. So that's the adjacent one. Finding the gear uses the same logic. The only difference here is that if it's equal to 1, which is the star, we will add a gear at that position. So that's what this is doing. And then we want to get the gear number. So here we have this number position. We put in another number position. We go through all the gears that we have added and then check if those X and Y positions of the different gears are exactly the same. Then we will multiply those together and put into our value here. We actually want to have a plus there. So we actually had just... we got a different number. So that was lucky that only 2 gears are close to each other. Only then we wanted to multiply these together. So we got something different if we did the plus here. So that is interesting. So that is, they check that we do that, and then we return val. So we only want 2 gears to be close to each other. So we did get that when we did the equal sign. I'm a little bit nervous about this because we have something here that is actually a bug, but it still works. So that is not really good. So we only want to find two gears that are close to each other. If we find more, that's wrong. So if we find one Boolean found gear, put false. And here it's true. If found gear, then return 0. Is that exactly the same? No, that is not the same. That is something different. But we solved it. So this, in my mind, would be more correct. Because we want to find one gear, and if we find two gears two values that are adjacent, we don't want to return that, because that is not a correct result. But then we get a different number than we actually put in. Interesting. So I will comment these out for the moment and check it in. But keep that in mind. We found something that I don't think is the right value, and we actually got the right value out. If you can figure out why this functionality that I wrote, that I think is incorrect, actually works, why the math works, please tell me in the comment section down below. And if you like this video, give it a like, share it with your friends and colleagues. If you have any comments or suggestions, leave them in the comment section down below. And if you want to show me your solutions, leave it down there as well. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.